Can everyone hear me online? All right. So today we're going to look at abstraction and creating your own functions and documentation of functions. So you could imagine if you had a really complicated program, putting it all into just like one big long stream of code would be somewhat problematic. So we need to have some way of breaking our program up into smaller pieces, and this is called abstraction. So abstraction is basically breaking our code up into smaller functions. And so you can imagine if you take a bunch of statements, put them together, and then replace where they are with a name, that would be the idea of abstracting them or making a function. And some of the reasons why we want to do that is breaking up code into functions makes it easier to read and therefore manage our programs. And if you're working with a number of programmers, by breaking it up into pieces, then you can assign the different pieces to different programmers. The other thing that we can use our functions to do is if we have code that's repeated quite a bit, rather than copying and pasting the same code all over the place, we can have it defined in one function and just call that function over and over again. Then if we needed to repair that function, we would just have one place to do the correction. So this is called the dry principle. Don't repeat yourself. And in programming, as a programmer, you should cultivate the desire to not have your code repeated in more than one location because it becomes a maintenance problem. So we don't want to repeat our code, so we define functions when we want to do things repetitively. So let's try this. Let's open up the Python shell and say fibs is equal to open square brace 0, 1. And then say for I in range 8 and put a colon. If you're in the interactive interpreter like this, when you put a colon, it's kind of interesting. You have to, it'll tab in for you. But at this point, then just type in fibs.append. And inside there, you're going to say fibs minus 2 plus fibs minus 1. And then see what you have in fibs. Zero, 1, 1, 2, 3, 5, 8, 13, 21, 34. And this is known as the Fibonacci sequence. And basically the idea with the Fibonacci sequence is that you take the last two numbers in the sequence, add them together, and that makes the next sequence. So if we look at this and we run through it in our mind, we would start off with fibs equal to 0, 1. And then we have I I in range 8. So I is in 0, comma 1, 2, 3, 4, 5, 6, 7. And so I will start off equaling 0. Notice that we're not using I in the calculation. The only purpose of I is actually just to loop multiple times. But we say fibs dot append when I is 0, fibs minus 2. What's fibs minus 2? It's going to be this 0. And then fibs minus 1 is this 1. So if I add 0 plus 1, I should get 1. And that gets appended. So now this list is 0, comma 1, because 1 is equal to 1. We then loop back around, and I is now 1. And then again, we're going to add fibs minus 2 and minus 1. So minus 2 is 1, and minus 1 is this 1 now. And so now this is 2. And then we are now on 2. We do this again. And we add 1 and 2, and we get 3. And you can see that we are getting the results in our list. Does that make sense how that function kind of works? Does that make sense online? Yeah, and this Fibonacci sequence is pretty famous. If you can see my background, I've got it there. But basically, if I take a square and I add another square, that's the 1 and 1. And now if I add a square of the, so this is 1, 1. Now we do a 2 by 2 square, and then we do the 3, 3, which is the next level, and then that would become the 5 and the 5. It actually starts describing a spiral, and that spiral is actually seen in nature a lot. It's you'll see in plants, a lot of leaves will feature that curve. In architecture, this ratio from this height to this height is often featured in a lot of architecture, and it just has for some reason that seems to have a pleasing appearance to human beings. So you'll see the Fibonacci sequence and also called the golden mean, that ratio used in a lot of architecture and art. So so you get some art history in this class too. So it would be nice if we could maybe write this as a function, which would say how many Fibonacci sequences do you want, and you'd put in 5. You get that. So it would be nice to have a Fibonacci function. And so we're going to learn how to define a function. And the way we define a function is we use the def keyword. We provide a function name, and the rules for making the names for functions is the same as for declaring a variable name. Basically, it's got to be all characters. It has to be no spaces in it, and you can have numbers and underscores, and it can't be preceded by a number. And then you can have 0 or more parameters in here. So if you have no parameters, your function will just be something like def my function, and you have open and close parentheses. That'd be parameterless. But you could also have def my function and param 1, comma param 2, and you can put as many parameters as you want in there. And then tabbed in, you have your code, and at the last bit, you have a return statement, and you can optionally return a value from your function. So let's try this. Let's put define hello name colon and put return hello plus name plus an exclamation point. And you're going to have to hit return twice here. So hit return 2 times here to get back to your prompt. And then try using your function. Say, hello world. So this is the function definition. And this is the call. Actually, this is the function call. Did that work? So when you run that, you get hello world, right? So that's basically how you define a function. You use the def keyword, and then you have a block of code defined by the tab, and then you make the code do what you want to do. Now try it again and put in hello and then Rob, or your own name, and see what it does. Is the sound quality okay? Okay, good. And so if you change the, notice if they change the parameter that this parameter world is going into that, or this argument, we say this is the argument, and this is the parameter. And so the argument is copied into the parameter and then is what comes out. So when we said world, notice it said hello world. When we said Rob, notice it said hello Rob. Does that make sense? So let's make a program this time. We're going to make a program that's going to have a Fibonacci sequence defined up here. And then in the main part, it's going to use that function. And so go ahead and type out the program. Notice very similar to, and then don't forget, and so here we need also parentheses. It's going to be very similar to the code we wrote. You might be able to copy and paste even some of it. But it's going to be a little different because we're going to have this parameter coming in. And we have to use that parameter. And then this will be the function call. And here we have a function call to that function. Okay, so when you do that, let me erase some of this stuff. So when you run that, try and run the program and then put in different values. Like put in 5, and you should get 5 Fibonacci numbers. Put in 3, and you should get 3 Fibonacci numbers. And then also notice that we have this enter to quit functionality. So it's using the while true here, and notice that it checks to see if there's an empty string. If the user just puts an empty string, it breaks. If they put in something, then it passes what they have for user input goes over here into num. So notice that even though it's called user input down in right around here, in the function, the parameter doesn't have to have the same name as the oops. Notice that user input is not the same as num, so it doesn't have to have the same. It doesn't have to have the same name as the parameter that gets passed in. And in fact, when this function calls, it actually just copies whatever this is into here. Does that make sense? And that would, and because you could run this by saying fibs and just put a hard-coded number in there like 5, it would still work, and the 5 would go in and be inserted into number. That work? Okay. Now, one of the things that is useful is documenting your function. So we have a function here. Let's see, did they do it? I guess, yeah, that's just the repeat of the same thing we just did. Okay, so you have the ability to make functions which return things, functions that don't return things, functions that take parameters, and functions that don't take parameters. So here's an example of a function that takes no parameters and returns nothing. So in a sense, it's almost like, well, this doesn't seem really like a math function type of thing, right? So let's define this one called test, and it just says this is just printed, and if you run it, normally if you were running this, you would just type in this section, test. But let's try this. Let's say x equals test, and then run it and see what you get. And then print x. What do we get for x? You get anything back? You should get a none. And the reason is that there's no return value. There's no return here, for example. It's not like it says return 5 or something like that. So in a function like this, where there is no return, you just get none. So normally you wouldn't run it this way. You would actually just run this without this part right here. You just say test, because all you're doing is you're just wanting to print out. So functions can have 0 parameters, and if they have no parameters, the function is just written with open close parentheses. And it can have a return, and it's optional whether or not the function actually returns something. So in this case, define my function param1, param2, return param1 plus param2. This does everything. It has parameters, and then it has a return value. So that's doing everything, but you don't have to do all of those. So let's try this one. Let's define this function, try to change, and we'll pass in n. And then we're going to say, we're going to see, maybe we could actually change n in the parameter and see what happens with that. So we're going to say name equals Mrs. Entity, try to change name, and then display name. So the question is does name get changed to Mr. Gumby? Turns out that you can't actually change things through the parameters. So even though we, here we have the statement where we change n, and you might think that that means that that would change name here. Notice that it doesn't modify it. So things get copied in the parameters into the function, but they don't get, the parameters don't get, if they get modified inside the function, don't get copied back out. Now, there's one little exception to this. Let's say that instead of just a primitive value, what we're passing in is a list or a sequence. So in this case, we're going to define change n, and we're going to say n at index 0 is equal to Mr. Gumby. And then we're going to make this list names equals Mrs. Entity, Mrs. Thing, and try to change names, and then display names. Does it change the list? Notice that the value is changed. So why is it that it changed? It didn't change in the previous example when we tried to modify the we try to modify something in here, but here we can see that this change does occur. So online, does that, does anyone online have an idea why that modification was made? Can you hear me online? Cool. Yeah, and the reason is basically realize when you were dealing with sequences or anything like that, it's actually a pointer to a place in memory. And so we're not really changing n here. Notice that n is still going to point to the same place in memory where these names are located. But what we are changing is the list that names is pointing to. And so in this case, if you pass in a sequence to through a parameter and you modify that sequence inside of the function, it will change the original sequence, unlike if you just pass a primitive value. So mutable variables, i.e. lists, can be changed this way. Of course, if it's a tuple or string, those are immutable. Those can't be modified this way. So let's see, what are we working on right now these days? So continue with functions. I think I'm going to continue on to the next level because we still got time. Let's see, grab the next presentation. So you can't return multiple values. You can't return values to the parameters. And you can only return one thing with a return statement. So the question becomes, how do we return multiple things from a function? Well, quite simply, just return a list. A list is one thing, but it can contain multiple objects. So you can return a list or a tuple. And so let's say that we wanted to write a program that inputs a full name and shows the first, middle, and last names on separate lines. So for me, it'd be Robert J. Garner, and then it would put each one of those on a separate line. And if no middle initial is provided, what we want it to do is just say no middle name. So it's got to look at this input and see if there's 2 names or 3 names, and if there's 2 names, then just put no middle name in between it. And so we're going to define a function that takes one parameter, the name, and have a return a list. And the list will have the first, middle, last names, and no middle initial in the second one. So write this function. Define split name, and it's going to pass in a name as a parameter. And then we're going to say namelist.split. What does a split function do? Yeah, it separates it based on white space, right? It could be spaces or commas or tabs or anything of that nature. So our function is going to split the name that comes in, and then it's going to check the length of the name list. If it's less than 3, it's going to assume that there's no middle initial, and it's going to go through this little algorithm. It's going to append to our name list the last element of the list, or the name list at index 1. So if it passed in like Rob Garner, it would become Rob Garner at that point. And then it's going to change the element at index 1 to no middle name. So then it would become Rob no middle name Garner. And then once it does all that, it'll return the name list. And so we're going to, then in the main part of the program, we're going to say, please enter name, input first, middle, last, or first and last. Pass that name string that we got from the user to the split name function. Split name is going to do all that stuff we just described and return name list. And then we'll iterate through that name list. So realize, this is a function that's returning 3 things, and but it's just using a list to do it. That work? We're still typing? Cool. So if we run this one, and you put in, for example, Aaron Aardvark, you should get Aaron, no middle name, Aardvark. This is actually a pretty common task that you might see happen. One of the things Python is really powerful at, I think, is if you need to just write ad hoc code to do like a one-time task. And one-time task that happens a lot is cleaning data. So this is not an unusual way of seeing an application develop. Someone in an office makes an amazing spreadsheet that does everything. everyone becomes dependent on the spreadsheet, and that person gets promoted out of the office, and no one knows how to maintain the amazing spreadsheet that we've all become to depend on. So what do? We hire programmers to come in and clean the spreadsheet data, put it into an application, and then actually make an application, which also gets rid of everyone yelling across the cubicles to please close the spreadsheet so they can put their data in it. But that super user was actually really powerful, and being able to do that is great. And one common thing is that people put in names different ways when they put in a name field. Sometimes they just put a single name field, which has a first, middle, and last name. Sometimes they have 3 separate columns. 3 separate columns is easy to deal with as a programmer. 1 column with everything in there, you might have to do stuff like this. So we're going to write a program together today. Let's say that the Python bank provides an online mortgage payment calculator. This is the formula for calculating a monthly payment. And you're not allowed to take a programming course without writing a mortgage calculator. I think it's like some kind of contractual thing. So we're going to write a mortgage calculator. I'm just kidding. So this is, and the reason why we like making mortgage calculators and programming is because it's a complex formula, and it forces us to have to deal with some complexity. And so I'm going to get it set up here so that we can try to write this program to do mortgage calculation. And if you write along, and so we got this formula. And probably the most useful part is trying to get it to give me my mouse cursor. Here we have the definitions of what it is. M is monthly payment, I is interest rate, P is the principal on the loan, N is the number of years, Q is the number of payments per year. And so we'll probably just assume that that's 12 and put 12 in here. But we could ask the user possibly for that. And so what we're going to do is we're going to present a header to the user, do another loop so multiples of these can be done. Ask the user, we're going to use ask functions to ask the user to give us our information. And note that when you have a percentage involved, which we need to with this formula because we have interest rate, we have to make sure that we tell the user what format we want it in. If we want them to put 5 for 5%, then we have to say that. But then we have to convert it to like 0.05 when we're doing a calculation often. So the user input will be important to this. So I'm going to open up idle, and I'm going to make a program, and I'm going to save it as mortcalc and put it on my desktop. And so if I were to write some pseudocode out, I'm going to have define functions up here, and then I'm going to have main here. And what I want to do in main is I want to get let's see, I want the principal. I want to get the interest, get number of years, and then maybe get and then calculate monthly payment, and then maybe display payment. And so, really I could conceive that I will have these as functions up here. So I'm just going to copy that over. And to get the principal, I'm just going to say define get principal And for this one, I'm just going to do an input. So I'm going to say maybe principal is equal to input. And I'm going to return principal. So this function is going to ask the user for what they want for the principal, and then it's just going to return it. And then I'm just going to go ahead and type that. I'm going to say P is equal to get principal. And then just to see what I got, I'm going to just display P. So right away, you can kind of see the functions really fit into, if you're writing pseudocode, the structure of your program. Oh, and I forgot a colon. One of the strengths of actually writing just a little bit of code and testing it. And I can see I can test my input function. I can see it's working. Then, my other get functions are going to be pretty similar. Find get interest. So I want my interest to actually be in decimal values, but I'm going to ask it for the user in percentages. And so I'm going to actually divide by 100 um, to make it be a calculable value. So I don't have to like do the divide by 100 in the formula calculation. And I'm going to then print I just so that I can see if I'm getting the interest. I'm going to run it. And I get a problem. What's the problem? Dividing a string by number, absolutely correct. So what I need to do is I need to do a conversion here. And so I'm going to convert that to a float. And then I get 0.07. that make sense? So I'm writing little pieces of code. I'm making little tiny functions. My functions are really small. And so in Agile, one of the thoughts is that really your functions should be kind of in the 3 to 5 lines of code range. They shouldn't be super large. And you should use a lot of small functions and rather than a big function. And you'll notice also that by having good names here, do I really need to have a comment that says get principal when the function name is get principal? Yeah, no. So I can actually, if I write my function names nicely, I don't need comments because my function names do the documentation. And so we say that these are self-documenting in a sense. And so then, years is going to be the same thing, right? Define, get years, and then years is equal to this one. We want to be an integer maybe. Input years, return years. And I've got my input functions. So now what I need to do is do my calculation. And so for my calculation, I'm going to define calc monthly payment. But I'm going to need some parameters. So I'm going to need principal, interest, and years. And there's this Q value, which I'm going to go ahead and define as 12. And then I'm going to look at my at the function, which is m equals PIQ1, all this stuff. Well, this is kind of a complex formula, so I'm going to break it up. And so I'm going to do this part first. I'm going to go from the inside out. 1 plus I divided by Q. So part 1 equals 1 plus, and let's see, I was interest, and that whole thing is divided by Q. So actually, I got that wrong, didn't I? It's 1 plus I divided by Q, just like that. Is that supposed to be a colon or a semicolon right after Q? Oh. Sorry, just was teaching a different language about an hour ago. So interest divided by Q and then add 1. And then, so I've got that part, and then it's raised to the minus n times Q. So part 2 is going to equal, I'm going to make that minus 1 times, let's see, n is the number of years, so that's years times Q. Part 3 is equal to P1 raised to part 2. So I've got all this piece. And then the part 4 would be 1 minus part 3. And part 5 is equal to Q times part 4. And then monthly is really going to be equal to the principal times interest divided by part 5. And then I'll return monthly. If you're comfortable writing the whole formula out all on one shot, you can. The nice thing about this is if I'm troubleshooting, I can just look at part 1, part 2, part 3, or whatever, and I can see what that part is, and that might help me solve it a little bit. I'll be able to easier to find things. And if so, I'm going to do that, and here I'm just going to say so. How do I call this function? I got to get a value back, so I'm going to put monthly payment is equal to calc monthly payment. And then I'm going to pass in not principal, interest, years spelled out like this, but since I have these variables here, I'm going to pass in, these are the ones that I've just gotten from the user. That's what I want to pass in. So P comma I comma Y. And notice that this in my arguments list here doesn't have to match the names of my parameters. The way this gets lined up is this value here is passed in by position. So P in my function call gets passed to principal in my function definition by position. I goes into interest because it's in the second position. Y goes into years because it's in the third position. So when you make a function call, the arguments, which these are the arguments, are passed to the parameters in the function definition based on their position. And just to see what we got, I'm going to say print monthly payment and run that. And so we'll say $10,000 at 5% over 30 years. Oh, run it again. $1,000, 5% over 30 years. I can't multiply a sequence by non-integer of type float. And our problem seems to be on line 26. So why does it say principal is a sequence? So let's see, what do we have for P? Ah, what's the problem? Principal is a string, exactly right. So here I need to convert this to a float. And then we can run it again. And we get 5368. So how can we validate this? Well, there's actually there's some mortgage calculators online. Let's see if I can find one. Mortgage calculator. And conveniently, Google gives us one, so I'll put 10,000, interest rate of 5% over 30 years, and I get 54. Is that what my results were? So yeah, I now have indications that it was working. And if I didn't, I could then look at P1, P2, P3, P4, P5, do some test cases and see what the intermediate results were and see if I was making some mistakes somewhere in my formula. By having the formula spread out along multiple lines, one of the nice things is that if you have an error, it'll point to the line, and if you have a calculation problem, you can look at, well, let's see what's in P1 or 2. Nope. Oh, I guess you can't find it because it's inside the function, but at least I can, it's a little easier to figure out what's going on. So now we need to display payment. So maybe we'll make a display payment function, and we'll just say define display mortgage info. And we're going to pass in pretty much the same things as are here. But I'm also going to pass in the monthly. And we can actually display a bunch of things from this. We can say print for a actually I'm going to use %s for a %s loan at %s interest over %s years and then we'll say print the monthly payment is %s. And we could actually do some things like this. The total loan cost is %s, and that would be monthly times 12 times years. Cost of loan, and I think I'm going to put that in a variable because I can use that. Total cost is equal to this. And then the if I subtract the principal from the total cost, that will be the cost of the loan. I think that's really total loan payment. And once I have that, then I can P comma I comma Y comma monthly payment. And let's see, years not defined. It's years. Format specifiers aren't working. Oh, because I didn't use percent here. There we go. For $10,000 loan at 0.05 interest over 30 years, the monthly payment is 53. The total loan payment is that, and the cost of the loan is $9,000. So kind of doubles over 30 years. Cool. So does that make sense? And things to review. One, notice a function it's optional whether a function returns something. Notice that our print function really doesn't return anything. It doesn't really need to. Yeah, so you don't, you do this, and you don't have a handle on what comes back, and then it doesn't work. So you have to typically, when you have a function that has a return, you're going to have an assignment operation to store the results into some variables, and then you're often then passing those variables to another function to do the next step of the process. So it would be unusual to have, like, you get a bunch of inputs from the user, you pass those to one function, you get a result back from that function, you take the variable from that, pass it into another function, you just keep doing that until you get the final results that you need. Now, one thing you could do is actually the functions can actually be just passed in directly like this. If this doesn't make, if it seems a little confusing, you can ignore that, but you know, I can actually take the output of one function and make it the input of another function. So of course that wouldn't work here because I need those variables. So it's not a great idea for this particular application. But you can take the output of a function and pass it in as a parameter to another function. Any questions online for that demonstration? Make sense?
Yes.
Cool.
It's hard to grasp, but once you start messing around with it.
Yeah, and you know what you do is just start like find a formula or something. Just write up, you know, a function or two.
Something for it.
Yeah.
I mean, that's how I'm learning, just by messing around with it.
That's the best way, and that's why the final project is really find something that you're interested in, and after you learn how to do this, the fundamentals, chasing down trying to make that program work is what really teaches you how to code. Cool. Well, that's all I have for today. The rest is lab time. If you need any help, let me know.
I might email you later tonight
Will do.
on the program, okay?
Cool.